Alright, finally I found the answer from this Stackoverflow post. My question is, let's say if I have a NumPy series 0, 0, and then 1, 1, 1, I only count the 1 and I restart my count from 0. When I see 1, then I start counting 1, 2, 3. When I see 0, then it goes back to 0. When I see 1 again, I count 1. And I see 0 again, then I reset to 0. And I see 2 1s here, then I start counting 1, 2, and so on. The reason why I need this, because I'm creating my own backtest. That's why I need to count consecutive up days and down days. It's for the further trade algo. Okay, but anyway, I just go back to my example because it's not that intuitive to me at first. So I just create an Excel file to explain. So A is basically my array. Okay, in the meantime, I'll be doing it in Python as well. Okay, the very first step is I have to create my array, right? My question. So my question is, I got an array. Let's call it A. Oh, before that, I need to import NumPy as NP. Okay, because I need to use NumPy to do that kind of thing. Actually, I just call it A equals NP.array wrapped around a Python array. So it's just kind of this. I think I will just paste these array. Let's go here. Just Control V. Let's see if I get 3, 1, 1, and then 1, 2. Okay, and then enter. And so when I print A, I'll get the array. I get the result. It will be counting from this position 1, 2, 3 back to 0, and then it starts counting 1, 1, 2. Okay. To do this, I actually am following this solution from Stackoverflow. Let me see who answered this. A big thank to DSM. Before that, what I do is I will set a variable called value to count, because I will start counting when I see 1. Okay, so I set it to 1, and I set the value to reset equals 0. So when I see 0, it will be 0. I will create an array called no reset. That is the array that I start counting when I see 1, 1, 2, 3. And when I see 0 again, it will be copying the value from the previous position. That is when it is in position 6. I see 0, it's not 1, right? But I'm not resetting it to 0. I'm just copying the previous position's value. Same as 7. When I'm in position 8, I will start counting. So 3 plus 1 is 4. That is the no reset. That is just counting without reset. Let's go back to Python script. So I just set a variable called no reset. It is an array, a list of number like this. When array A equals value to count, which is 1, and it is a Cumsum, it just accumulates the previous number. So just press enter, and then let me print no reset and see what we get. So we will see 1, 2, 3, 1, 2, 3, and when I see 0 in position 7, starting from left to right, at 0, so I'm not counting, and that's why I'm copying 3. So when I see 1 again, then I'll start counting. 3 plus 1, 4. Okay, and so on. According to the solution, we need to create another array called reset. Okay, let me explain. So when I set the array, this array, the list of number, when it's equal to 0, just like position 0, position 1, these 3 positions, when this one equals to 0, then it will be true. It's just like when I see true, it's 1. When I see false, it's 0. So when the value to reset, which is 0, when the reset array is not 0, which is 1, then I return false. Okay, so I don't count it. Let's go back to Python. And what I need to do is create a reset array equals A, which is our NumPy array, equals value to reset, which is 0. So just put enter. I should see a whole bunch of true or false like this. Okay, let me print that out. Reset, and you see true and false, just like this one. The next one is access. Basically, what they need to do is when we have a whole list of number minus the access, and you get the result. Okay, I'll just go slowly because I didn't understand at the first time either. We are not printing this one because the no reset times reset is here, but I just list it out in Excel just for explanation. Let's say if we have no reset, which is this row, the list of number times the reset. When you see 0, 0 times anything is 0. So it's for position 0 here, you will get 0. For position 1, you will get 0 either, because 0 times 1, 0. 0 times 1, 0. And for this one, position 3, 4, 5, even if your no reset array has number is 1, 2, 3, right? But it's multiplying a 0, which is false. So any number times 0 is 0. When we are getting to position 6, our no reset array equals 3. And our reset array equals 1, which is true. So 3 times true, that means 3 times 1 is 1. It's the same as position 7. So whenever you see F or 0, you'll get 0. That's the situation in position 8. But for position 9, we have 4 and we have true. So we get no reset times reset equals 4. So when we have the no reset, we have this list of number. Let me print that out in Python. So it's printing no reset times reset. So you get this. We need to create a column called access. The access is the maximum accumulate of the NumPy package. It's the function called maximum accumulate. So it's going to accumulate what? It's going to accumulate the previous row that we create, which is the no reset times reset. It's this one. So actually it's so easy for these 3 positions. The maximum is 0. And for 3, we have 0 because we have 0 all the way until position 6. So we have 3 and 0. So 3 is the maximum number. From position 0 to 6, the maximum number is this one. So the accumulated maximum is 3. So for position 7, we got 3 again. So the accumulated maximum of this blue array is still 3. But for position 9, we see 4. And 4 is the maximum number of the blue array. Okay, so we return 4, 0. Okay, and this one we see 6. That's why we have the access row like this, right? So once we get the no reset and the access row, we can start calculating the result. Okay, let me print the access row in Python. I'll just call it access equals numpy.maximum.accumulate of what? Of no, excuse me, copy this one because I pressed the wrong key. The no reset times reset. So when I print access, I should see this, right? The access row. 3, 4, let's go to our final part, the result. That's what we want. So when we subtract the no reset array by the access array, which is this one, 0 minus 0, 0, right? I just skip all those positions with 0. So in position 3, index equals 3, our no reset array equals 1. And our access array equals 0. So 1 minus 0. No access minus access is 1. And 2 minus 0 is 2. 3 minus 0 is 3. And 3 minus 3 is 0. That is just like when we see 0, we reset the result array to 0. So in position 7, we have 3 minus 3, which is 0. In position 8, we see 1 again. And our no reset array is 4. And our access array is 3. So 4 minus 3 is 1. And in position 9, we see 0 again. And we have 4 minus 4, which is 0. And so on. In position 10, we see 1 again. We have 5. 5 minus 4 is 1. 11, we see 1 again. And we jump from the no reset array. So we got 6. 6 minus 4 is 2. And the last one, it goes back to 0. That means the no reset doesn't jump. So it still remains. It remains at 6, and 6 minus 6, the access array 6, so it's equal to 0. That's why we get the 1, 2, 3, 0, 1, 1, 1, 2. That's the result. Let's print that out in Python. So I just call result equals no reset, which is the original array, minus the access array. So when we print the result, we will get 0, 0, 1, 2, 3, and it goes back. So it's just like this. It's in position 4, 0, position 3, 1, 0, 1, 2, 3. The position 3, I see 1, then I see 1. I see 1 again in position 4. Then I start counting. 1, 2, 3. When I see 0, I just skip it and keep it at 0. When I see 1 again, I start counting. When I see 0 again, I reset it to 0. When I see 1 again, then I start counting. That is what we want to accumulate a NumPy array. Actually, it's very useful for counting trend day for any trends. So that's why I'm recording it for my reference, and hopefully it can help you also. Thank you. Bye bye.